Welcome. I'm here with Andy Munitz, Andy from Sony. We are here to talk about Sony's digital wireless line.
10 years ago, the componentry finally became available, and our engineers felt we could now develop true digital transmission wireless in a small portable package. It would have been one thing to just make it in a studio package, but we try to do a whole family. Obviously, a large part of what we do at Sony is camera technology, and we sell lots to, news crews and, E&G and Hollywood for digital cinema and all those kind of things, as well as, videographers and corporate and so on and so forth. But we wanted to be able to do a whole family of digital wireless transmission. So we developed something called the DWX series. And what is unique about the DWX series is that it is true digital transmission, whether you're starting at a body pack or a plug-on transmitter or a handheld transmitter, microphone.
And I think it's worth talking about what are some of the advantages of a true digital transmission?
Absolutely. I would have to say there's a few. The first one is ultimate sound quality. Since when you kind of go into your mic pre from an analog source, and then you go through an A to D converter, now you're in the digital domain. You got bits, you got ones and zeros. We transmit bits, ones and zeros. We're still in the digital domain. We hit the receiver, it's still in the digital domain. If that's inside of a camera, it goes directly into the video file, it goes through post-production editing, it goes through transmission to the home. It's still digital. The only time, and the very first time, it goes back to the analog domain is at the D to A converters that are in front of the playback speakers.
So literally from the actor or presenter's mouth to the speaker, those are the only two analog points.
The only two analog points.
Yeah.
Certainly if you've got a digital mixer on set and you're feeding, digital out at the rack receiver, you're staying digital. It can go and literally stay. But the benefit there is that since we are transmitting bits, a bit stream, there is no reason for a companding scheme. Companding isn't even part of this equation, so there's no chance for any audio artifact due to a companding scheme. And that, to me, is the real beauty of this. This stuff is clean as a whistle, and to my ears, and I've tried to do some careful testing, identical to plugging in a mic with a cable.
Yeah.
So that's a huge benefit. Another smaller benefit of digital is you can do encryption. And encryption may be important if you're working on, big episodic TV, giant movies. I mean, if you were, doing the new Star Wars feature and you didn't want paparazzi sitting around the corner from wherever your shoot is, listening in and learning the plot lines, that can save you a lot of hassle and a lot of embarrassment by getting that story out.
Do you know, because people ask sometimes what level of encryption, do you know the level of
This
encryption?
is 128.
128
It
bits.
is.
Okay.
But you can do one transmitter to one receiver or one transmitter to multiple receivers. They can all be on the same flavor and the same family. And actually, the White House has been using this digital wireless from us for many years because of the encryptability of it, which is kind of cool.
Yeah.
So that's another, arguably a smaller benefit of digital. Sonically, it is very important. I think also that the amount of power that you need to cover the same range, the difference in the signal to noise of a digital bit stream versus background noise, there can be a much wider ratio of signal to noise, and the receiver can still pick out the digital bit stream. So you don't have to have this crazy amount of power. So as a matter of fact, these have a setting of power from 110 or 50 milliwatts. And people generally think, more is better, let me crank it up to 50. But that would be a mistake, especially if you're in a normal kind of 10, 15-foot distance thing.
Right.
Overdriving the input circuitry can actually harm your digital bit stream. So you should try to operate at 10 milliwatts. If you're 100 feet away or whatever, you're driving away in a car or something, by all means, put it on 50 milliwatts. But don't instantly think that it's the same, it's always going to be better. And you can't exactly say that the power output on this is apples to oranges of the settings that you're used to in analog world.
And while we're comparing to analog world, talk to me about the spectral efficiency of digital transmission.
Very good question. We do live in spectrum challenging times, and it's only going to get more so. If you have actually earlier I mentioned that we all operate in this, both of our systems operate in UHF 14 up to 51, and we kind of split the ranges into 3 bands. Actually, in this big receiver here, this one receiver can cover the entire range from 14 all the way up to 51. It can tune in 7,600 and something channels. So that's interesting. Our body packs, our plug-ons, our transmitters, we all kind of put them into 3 ranges.
Those same 3 ranges the
Right.
analogs.
But a lot of times you exist in a world where you have to have compatibility with analog wireless. They need to coexist in the same place and time. So we have groups that are built into the digital wireless that are analog compatible groups that will allow for low intermod. But in a purely digital transmission scheme, intermod problems are minuscule, especially compared to analog land. And that means that we can fit many more channels into a given UHF TV channel white space. Where in analog land, on a UHF TV channel, we generally say you can fit 8 wireless mic analog channels within there without intermod, and they'll be mathematically pre-tested and all that stuff. And they would not be evenly spaced, as a matter of fact, throughout that 6 megahertz wide TV channel. In digital land, if all you have is digital microphones and digital wireless transmission, you can actually fit 50% more channels in that given space. So it is more spectrally efficient.
Yeah.
But what we are doing here is keeping, in that scheme, we are keeping the quality high. We are not reducing, frequency response, any of that stuff. So, and that does bring up a point of codec. We are definitely a digital scheme. So we go from the analog domain into the digital domain and then back out of it at some point. But the codecs that get used to go from analog to digital have to be designed. There are companies that make off-the-shelf codecs. And for anybody that has dealt with Sony on our broadcast video side, they're well aware that if anything, we're a codec company. You can almost blink and, we got another codec, for our video cameras, be it XD-Cam or XAVC or AVC-HD, all that kind of stuff. But we did not want to just use an off-the-shelf audio codec for this, so we designed our own. Because when you design a codec, you have to balance out 2 things that sort of play against each other. Latency versus how long you can take to do a higher quality conversion from either A to D or D to A.
Right. The more complex the codec, the longer it takes to encode and decode.
Exactly. And latency can be an issue. So we designed our own codec that was equivalent to 24-bit 48K quality with a latency of a max of about 3.4 milliseconds, which is, me being only, 3 feet or so away from you. We have, by the way, just introduced our N-series versions, which is really our 3rd generation of the DWX. And one of the benefits of that is you now have a choice of 2 additional codecs. So there are a lot of opera houses in Europe that love our digital wireless for the way it really sounds. But they wanted to have a codec that was even faster. A lot of times in performance, you will have on stage people with in-ear monitors, for example. And just take this as an example. I'm a performer, I'm singing, my signal's going out to, the receiver, which is going through the on-stage monitor board, and then back out to a transmitter, back to my in-ear monitors. And if that round trip is a little too long, the singer in their head, it just won't sound quite right. So having a very low latency is important. So in codec 2, which is one of the new codec choices in the N-series version of DWX, we can now bring that down to a maximum of 1.5 millisecond, which has got to be an industry kind of leading points. So very, very fast in terms of that.
And so what's the flip side of that coin? Any compromise in that?
No compromise in that, no. We have codec 3, which adds an extra layer of error correction that gives you potentially, it's not a spec, but my sense is about 20 to 30% additional distance of transmission. It could be important for a huge film set. That would have to be a really big one, or for broadcast sports or things like that. And the trade-off there of that extra layer of error correction is you get out to about 4.5 milliseconds of latency. Again, not a really huge issue. Okay. But our engineers at Sony are kind of always trying to think of unique things they could do that would enhance the usability of anything. The question you originally started out with is, what are some of the benefits of digital? And this one that I'm going to tell you about is really I like it. It's really interesting, and it can really help out. And that is remote controllability of a transmitter. Imagine you got this transmitter, it's a body pack, it's all wired into Talent, they're ready to go live, they're doing their shoot, whatever it turns out to be, film, news, whatever it turns out. And you're the receiver, and you're listening, and you say, I got to adjust their mic pregain. The wind just came up. I got to dial in a little low-cut filter frequency. So wouldn't it be cool at a distance to be able to remote control all the settings on that transmitter? And that's what we do through a specific architecture that we call cross remote. Cross remote is different from the transmission of the audio, which is arguably the most important thing, to go from a transmitter to a receiver. That's job one. By the way, since this is a digital transmission scheme, we can add additional metadata information from the transmitter and have it be embedded in the bit stream to go back to the receiver. So I can put in that embedded bit stream, what's my battery life, what is my frequency, obviously, what's my power output, what is my low-cut filter setting at, what's my mic pregain, what's my name that I've assigned to the transmitter. All that metadata gets added for free. It just gets sent back with the transmission scheme. So you're not really using up any extra juice, and it's at the receiver. But this cross-remote capability allows you to control the transmitter from the receiver. And even in our shoulder cams, even some of it from our cameras, from the front of the receiver, from the menu of this receiver, from a PC that is controlling, 82 channels of this stuff, from, to a degree, a cell phone app that we have. And in order for this remote control to work, we have to pair up a transmitter with the receiver channel. And we do that one time only. It's sort of like Bluetooth pairing, but in this case we use what's called 2.4 gig Zigbee. It's a different architecture. It's not quote-unquote Wi-Fi.
And we should talk about Zigbee is closer to Bluetooth than it is to Wi-Fi, meaning specifically it's very, very robust in terms of interference.
Exactly. And once they're paired, you can power these on and off, power these on and off. They still recognize each other. So let's do a quick pairing maybe just to show how easy it is.
Sure.
So what you would do to the quick shortcut to pairing, by the way, is instead of going through the menus, you literally hold down the minus button, and you power the unit on. And now it says scanning. I am discoverable. And then you put it down, and you pick your receiver channel. You hold down its minus button. See if you can see that there. It's got a minus button here. And you hold that down, and you hit it on. And now it's scanning, and it's looking for any discoverable transmitters. And it found it, and it's flashing it at you. And if you had multiple ones you happen to have in that mode, you could choose. But you just say selected. And now they're talking to each other. They're sharing information between the two of them.
And I can scan now for free frequencies on this receiver.
Exactly.
And I can even then, through this Zigbee link, change frequencies on the transmitter.
Absolutely.
So I don't have to deal with IR sync anymore.
You can have up to 30 feet away nominally with a transmitter body pack. But if you notice on the receiver now, right here is, if you can see, there are two little arrows facing in opposite directions with a little power level. And it's actually the same thing on the transmitter, and that shows that they are paired. So that's kind of, a nice thing. Now, the pairing step, this remote controllability, allows you, like you were just saying, to change the following functions with the transmitter at a distance. So you can obviously scan for a new frequency in about under a half a second, have it rechange the transmitter to that new frequency. You can change up to 15 different low-cut filter settings. You can change mic pregain. You can even change its power output from 1 to 10 to 50 milliwatts. So in the middle of a shot, you say, guy's walking far away, you can change that. You can even remotely put the transmitter to sleep. Say this is all buried under, costumes and everything, and it's time for a lunch break. You wouldn't go, excuse me, Miss Streisand, can I reach under your clothes and turn off your, save some batteries? But you can do that from the receiver, put this into a low power state so that when you come back from your break, you can just remotely power it back up and get going again.
Fantastic. And also that all applies to the plug-on as
transmitter as well. Now there's one more thing that I just want to mention.
Sure.
In our rack receiver, this is meant for studio application, for mobile card application, things like that. But in that kind of a situation, you could envision where you would want many of these receivers hooked up to a closed network, so that this could be on a network with up to 6 PCs, one in each different control room, for example, and you could have these receivers all in multiple studios even. But one of the benefits is that remote controllability. So we were saying that this and this guy gets you a 30-foot diameter range, 30-foot radius range, a 60-foot diameter circle of coverage. But say you wanted to add to that. Well, we make this guy right here, which is a cross remote, if you can see the side here, it's a cross remote transmission antenna. And you can put up to 9 of these on the network and assign them each their own IP address. And they can be put, and they're even powered over Ethernet. So they can be put in multiple areas of the set, or multiple studios, or one out on the commons, or whatever you want, up and down a hallway, for example, when you have actors going out into the hallway for a bit.
And they become a kind of mesh network, is that right? So that each one adds to the range.
Exactly. And it's just, and so that can all be on the same network. Now, additionally, on that network, with PCs, with those if you want, you can add a little Wi-Fi router, something you'd buy at, just an electronics store for your home, Wi-Fi. And you can then download a free app, iOS or Android, on your phone or tablet. Then you tell your phone or tablet, look and find that Wi-Fi spot, that Wi-Fi access point, run the application, which is free, and it will put up any wireless transmitters or receivers that are on the network, and it will even show you ones that are specifically paired, this channel to that channel receiver. They have that cross remote capability. And then through the Wi-Fi app, you can control many of the functions of the transmitter, many of the functions of the receiver. You can rename everything. You can, change. You can monitor reception strength. You can turn on a signal generator inside of here, so you could literally walk around a set and you could look for dips in coverage, and you could rename antennas.
There's a waterfall app associated with it, a little on the PC side. Is that right?
How do you mean a waterfall
Like,
app?
when somebody walks around, can I see where the dips were? Will it record that over?
Yes, there is. There's a full graph ability. It's called a chart grapher on the PC. And you don't need the PCs
Right.
to do that phone app, by the way. You can just add, one of those Wi-Fi routers to the back of these things. But you can, on an individual channel basis, call up the chart grapher, and you can see your A tuner strength, your B tuner strength, the resulting combo diversity reception. You can see a bit stream quality moving graphs. You can see if it took a hit. You can see where the dips are, depending on where the transmitter was.
It's a very, very powerful system, and we set these down to 10 milliwatts and got all kinds of range at the debates, and it sounded great. I'm a little bit worried for time.
Yeah, absolutely.
And I would say that really to experience this, please call us in New York or Atlanta. We'll arrange for a demo. We want to get the digital systems out to our cart users, but either system we're behind. I mean, these systems work under really adverse conditions. I also want to say, and I'm speeding through it a little bit just in the interest of time, for my cart brothers and sisters, a lot of manufacturers say their equipment is meant for use on location. You guys walk the walk and talk the talk. There's 12 volts on the back of this. If we had time, we'd flip everything around. But
on the rack receiver?
On the rack receiver, it is, there's a 4-pin input. That's really great to see.
Yeah.
And in addition to cascading outputs, and so you could build a system. Of course, I wish it were more than just 2 channels in a rack, but I'm happy to see that it's totally wideband.
One thing that I've been toying with making up is taking 3 of these little buckets and tying 3 next to each other with just a connector plate that would connect between these screws, and then you would have effectively 6 channels in a single rack side by side. Not bad.
Sounds like a project that we could sink our teeth into.
Yeah, I'd like to do it.
All right. Thank you. Before we break away, any questions? Anyone? No questions. All right. So these are available for sale and soon for rent. Give us a call, New York or Atlanta. We are happy to answer your questions, and we want to get these in your hands. As always, you can find us on our Vimeo and YouTube archives. Your ideas, Facebook and Twitter, tweet us your ideas. Send them to info@gothamsound.com. Andy, thank you so much for coming.
Thank you very much. Really appreciate it.